Hello, everyone. Am I audible? Okay, fine, guys. Let's start. So, guys, in our last class, I was talking about optimizer, I think, and in this class again, we'll try to continue with the same discussion, right? So, like I think we talked about SGD, we talked about BGD, we talked about MGD, right? And in this class, so again, so ADA data we have discussed. I think ADA grade we have discussed. We talked about like RMS prop, right? So and again, Adam optimizer, I think this is something like that we were talking about. So let's try to like continue from the same place, like Adam optimizer, and then we'll talk about a loss function, and probably if time allows, then we'll start talking about the TensorFlow, right? TensorFlow, then Keras, and then PyTorch we'll be talking about. And this is like how we are going to start practical with a like a small step, by taking a small step. Okay, so just give me a moment. Let me open up my slides. Okay, so your batch is DL 25th July, and we were talking about activation loss on optimizer. Okay, so this is something that we were talking about, and your recordings are up to date. So here you will be able to find out your class recording. So where I was talking about like optimizer, right? So these things are already available. Okay, so let's try to understand that what is a RDM optimizer, and then how it is going to work, how it is going to behave. So I think we all understand a meaning of optimizer. We don't have any kind of a confusion with respect to that. What is the meaning of optimizer? And I think you all are able to see my screen, ADAM, right? So adaptive momentum optimizer, right? So this is the full form of this optimizer that you will be able to get, adaptive momentum estimation. So if I'll talk about the full form of this optimizer, so it's nothing but adaptive momentum estimation. Okay. Now, so we all know about momentum, right? So momentum simply means that, so whenever we are going to consider a fact that whatever changes which I'm going to make, right? So whatever changes I'm going to make, so that changes depends upon. So whatever changes I'm going to make, so that changes should depends upon like that changes should depends upon like both. So whenever the changes depends upon like the kind of a changes that we have done in a last stage and the changes that we are going to do in this stage. So if that is something that you will be able to find out, or that is something if you will be able to get, so that is basically like called as a, that is basically called as a like an optimizer. That is basically like a this is where like you will be able to find out the concept of a Adam, or that this is where like you will be able to find out the concept of the adaptive momentum optimizer. So let's try to understand that like what is this adaptive momentum optimizer, and then how we are going to apply this adaptive momentum optimizer at any point of a time in a real time. So we talked about like a ADA grade optimizer, we talked about ADA delta optimizer, we talked about like RMS prop optimizer, and we have seen that just to control a learning rate, right? So whenever we will try to start the training, so maybe we can try to start the training from a predefined learning rate, but going forward, right, going forward when it will try to learn something, so we are not supposed to follow a similar kind of a sentiments, we are not supposed to follow a similar kind of a learning rate, the way we are trying to increase or the way we are trying to decrease a weight. So we are not supposed to like a decrease these things by taking a same factor of a gradient, right, same factor of a gradient. And this is where like a learning rate will comes into a picture. And to realize these things, people have started introducing a momentum. So people said that okay fine, so researchers have said that okay fine, so let's do one thing. So whenever you are trying to like change like a you're trying to like change, or you're trying to change the weight, you're trying to update the biases, so don't try to consider a same constant like a learning rate. Let's try to like change it, and which should vary depends upon the previous changes that you have done. And keeping these things in a mind, keeping these things in a mind, so there were a different kind of a optimizer that comes into a picture. Now the new optimizer, or the next optimizer, or one of the most powerful optimizer that we are going to learn and we are going to utilize, this one is called as a Adam optimizer. So adaptive momentum estimation optimizer. Now if I'll talk about the equation, right, if I'll talk about the equation of this optimizer, so here this is how you can try to write the equation of the optimizer. So here the new weight, if I'm trying to define, so it's nothing but what, it's a old weight minus, you can say, you can try to write in this way, that eta, which is nothing but a learning rate. So I think we all are aware about the eta factor, right, divided by, right, so eta divided by, you can try to write a v of t plus epsilon into, you are going to multiply by mt, right. So this is something that you are supposed to write, or this is something that you are supposed to do. Now what is the meaning of vt? Because in last Adam optimizer, Ada grade optimizer, RMS prop optimizer, we have seen basically a gradient square, right? So we were trying to divide it by the gradient square, and plus epsilon is nothing but it's a relation factor, so where value of epsilon is nothing but 10 to the power minus 8. So when this particular factor will be equal to 0, so in that case like the entire thing should not go to the 0. So this is what we have discussed. Now this is the formula, or this is the equation of a Adam optimizer that you will be able to find out. Now the major concern is, let's try to understand what is a meaning of this one and what is the meaning of this one. If we are able to understand a meaning of this one, I think we are good, because we know that meaning of this one is nothing but 10 to the power minus 8, right? It's a simple constant that we are going to use, so that even if this factor is equal to 0, so this entire thing should not be equal to 0, right? So that's the reason, so we have used this particular one again. So this epsilon values you can try to take as anything, and both things are going to be a fine for you. Okay, so I think there was a small disturbance because of phone. Okay, yeah. Now, so this is what the equation says, right? This is the original equation that you will be able to find out. Now let's try to understand a meaning of VT, and now let's try to understand a meaning of MT. If you are able to understand a meaning of VT, if you are able to understand a meaning of like a MT, so I think this Adam optimizer will be done, and you will be able to understand that how weight changes happens in case of a Adam optimizer. Now, so if I'll have to write a equation for a VT, right? So equation of V, like a On top of that, v cap t, if I have to write this equation, so how I will be able to write this kind of a equation? So equation for vt is nothing but, or v cap t is nothing but, so vt minus beta t. So it's nothing but a vt divided by 1 minus a beta t at any point of a time, at any time. Or equation of mt, if I'll have to write, so again equation of m, like a cap t is nothing but, so mt divided by 1 minus, right? So 1 minus again a beta t. So here beta 1 we used to take, and here beta 2 we used to take. So again we have end up introducing a new variables, right? So beta, we don't know, we don't have any idea, beta 1, beta 2, so we don't have any kind of idea. Or again, if I'm talking about this vt or mt, so I don't have any idea that what I'm talking about basically, right? What is the meaning of mt, or what is the meaning of a vt? So let's try to like understand that what is the exact meaning of mt and what is the exact meaning of a vt. So basically mt, right? So you can try to define mt is nothing but, so beta 1 m at t minus 1. This is a little bit like a lengthy equation, but yeah. So this is how you are supposed to like, this is the original equation, this is the actual equation, and from this equation itself, so we are trying to derive many more things. So here, if I'll try to write mt, so mt is nothing but, right? So beta 1 or m at t minus 1, plus we can try to write 1 minus beta 1 into gt. So 1 minus beta 1 into gt. This is the equation that we can write for mt. So this is the equation that we can write for mt. So mt is nothing but mt minus 1 plus 1 minus beta 1 into gt. And whenever we are trying to write the equation of vt, so equation of vt you can try to write in the similar way, the way we have written this like a mt equation. So here you are supposed to take a beta 2 v t minus 1 plus 1 minus beta 2 gradient square, right? So this is how you will be able to define the value of mt and bt, but still this value of m or v is unknown to us, and beta 1 and beta 2 is unknown to us. We are not sure, or we are not aware about these particular values, that what is the actual meaning of like these two things. So basically mt and vt are the estimates of a first momentum, right, and the second momentum. Now what is the meaning of a first momentum, or what is a meaning of a second momentum? Let's try to like understand this particular part. So when I'm saying that mt is nothing but, mt or vt is nothing but, so mt is basically a first momentum, or you can say the average of the momentum, and the vt is nothing but basically it's a second momentum, or you can say that it's nothing but it's a uncertain variations that we are going to consider as a vt. So mt is nothing but it's a mean, it's an average of the momentum, and vt is nothing but it's a uncentered variances that we used to like that we used to take with respect to what, with respect to the gradients. So here in this particular equation you will be able to find out gt value, right? What is gt? So gt is nothing but our d by dw, it's a gradient, right? It's a gradient that we are trying to find out. It's very simple, right? So gt is nothing but it's a gradient that we are trying to find out. Now whenever we are trying to talk about mt, so whenever we are calculating mt, so we are supposed to take what? We are supposed to take all the average of the gradient, right? So whatever gradient that we have calculated in a past, so we are supposed to take the average of all the gradients, right? And this is how I will be able to define the value of m. It's a simple momentum algorithm that we are talking about, and momentum simply means that whenever you are trying to calculate a new value, right, whenever you're trying to calculate the new value, so you are supposed to consider all the previous values as well. Now the way every algorithm try to use a different value is different, right? So here I'm trying to say that okay, so mt is nothing but, so m till t minus 1 means till t minus 1 whatever average gradient that you have, right? So you are supposed to consider that one, right? And gradient is nothing but d by dw, means whatever changes that you have done, so average of that you are supposed to consider, right? Multiplied by some kind of a constant. Beta 1, beta 2 is nothing but it's just a constant, it's just a relation factor that you are supposed to consider, right, at any point of a time. So generally like beta 1 or beta 2 are the values which we can try to take, which will be close to the 1. As simple as that. So beta 1 and beta 2 is nothing but it's just a regression factor, right? It's just a variables that we are trying to take, and this values can be like a zero point 0.9, zero point 0.8 I can consider, maybe 0.7 I can consider, maybe 0.6 I can consider, right? But here MT will be nothing but average of the gradient. And whenever I'm talking about a VT, so VT is nothing but it is going to be a variances, right? Uncentered variances, we used to say, means if suppose if I'm trying to like move from one point to another point. Suppose I'm trying to move from x1 point to x2 point. Now, so let's suppose I'll start my car here, right? So at this point of a time, maybe my speed is 0. Now at this point of a time, in between this route, in between this route, so my speed is not going to be constant. It could possible that my speed can vary, right? It could possible that my speed will vary. So at some point of a time, it will be 10, some point 20, some point it will be 60, then again 10, maybe 80 at some point of a time. So you will be able to find out that here, right here, my data set is varying in between what? In between 0 to 80. Right here, my data set is varying in between 0 to 80. So whatever speed that I'm able to achieve in between these these 2 points are nothing but it's a fluctuation in between 0 to 80 that I'm able to find out. So basically, the VT is a factor which try to consider basically our variances, right? Uncertain variances is try to consider, and M is nothing but it's a mean, it's an average. So V is nothing but variance, or M is nothing but mean. This is how you will be able to remember it. So here in an Adam optimizer, people said that okay, so why we are trying to divide, right? So why we are trying to divide all the time with a summation of a gradient? This is what we have done in a ADA delta. This is what we have done in a RMS prop. This is a same kind of a things we have done in a like a ADA grade as well, right? So people have given a logic that no, why we are trying to do that, right? Let's try to do one thing. So let's try to introduce this factor as well, because here whenever you will try to train any kind of a model, right? Whenever you will try to update the weights, training a model simply means that updating a weight, updating a biases. So people have given a logic that, okay, so it's good possible that sometime I'm supposed to decrease it, but not in a same pattern, or sometime I'm supposed to increase something, not in a same pattern, right? So basically it should also depends upon the variances, the kind of a like data, the way it is going to vary, right? Till a last step, so it should depend upon that as well. So whenever variances is going to increase, let's suppose if you have decayed something, let's suppose if you're trying to decay something by a huge volume, right? So again, we should consider that factor as well. Suppose sometime you have decayed something by a small volume, you're supposed to consider that small volume at that point of a time. And keeping these things in a mind, so people have given a logic that okay, fine, so this time in this optimizer, what I will do is I will try to consider average factor, plus I will try to consider what? I will try to consider this variance factor as well of a gradient that we are going to calculate. And this is where people have introduced this term called as V, and people have introduced this term called as M. So M simply means that it's an average or it's a mean of the gradient, and V simply means that it's a variances of the gradient that we are going to consider, right? A non-centric like a variances we are going to consider in this particular factor. And if we are going to consider this, because here we are not using a G, a small g or a gradient directly in a Adam like a in a ADA delta, in a RMS prop, or in a ADA grade. So what we have done is we have directly used a value of G, right? We were trying to multiply with the value of G, means d by dw. So whatever gradient that I will be able to find out, I was trying to multiply with that. But in this one, we are not trying to multiply with that one. We are trying to multiply with what? We are trying to multiply with the average. The average that we will be able to find out till m of t minus 1, right? And the current gradient at time t, right? That's the reason. So we have introduced a factor t minus 1. So average till t minus 1 and gradient at time t, right? So I'm going to consider gradient at time t as well as I'm going to consider the average that I was able to find out till t minus 1, right? And in this case, I will be having a much control, like I will be having like a better control over to the changes which I'm going to do in a old weight, because this is the control that we are supposed to achieve. This is something that we are supposed to control at any point of a time, because depends upon this, my entire like learning depends, or my entire learning happens at any point of a time, right? So keeping these things in mind, so this is the MT and this is the VT that people have introduced. And this VT is nothing but it's a variances, epsilon is nothing but it's just a constant factor, and MT is nothing but it's a basically average changes that you will be able to find out. Now, so people said that okay, so I will be able to find out average, I will be able to find out this VT. That is fine, right? That is fine, but I'm not going to utilize it directly, right? What I will do is I will try to use v hat, I will try to use m hat. So here in the original equation, you will be able to find out v hat and m hat. You will not be able to find out v or m directly. So people have given an argument that, okay, so we are supposed to introduce some regularization even for this average that we are trying to find out, MT, and we are supposed to like introduce some kind of regularization for like a VT as well. And keeping these things in a mind, so they have divided in a denominator, right? In a denominator, so researchers have taken basically 1 minus beta constant, like it can be in between 0 to 1 and close to 1, you can say like a 0.9, you can say, maybe you can try to take like a 0.8, 0.9 or somewhat like that, you can try to consider, right? So people said that, so suppose if by VT is equal to 10 and divided by, if beta 2 I have taken is equal to 0.9, so it will be nothing but 10 divided by 0.1, so in total it will be equal to 100, right? This is what you will be able to get, right? So if this is something, so variances will be equal to 100, or v hat you are going to consider as a 100 in this particular case. Or in case of MT, same thing will happen. If I'm going to take beta 1 is equal to, let's suppose like a 0.8, right? So let's suppose my m is equal to 10, so 1 minus 0.8 I can try to consider, and in this case basically it will be 10 divided by 0.2, right? And in total, so it will be equal to 50, right? So this is what people said that, okay, fine, so let's try to regularize this one as well, let's try to control changes in this one as well, right? Because at some point of a time we should control a mean, means the average changes that we are trying to consider, and at some point of a time we are supposed to control our variances as well, because variances is something which depends upon the gradient, right? Variance is something that depends upon the gradient, and here people have taken a gradient square basically. So here people have not taken just a GT, it's a gradient square that we have taken in a variance equation, and it's a gradient term that people have taken into a mean equation, right? In a mean equation. And finally, this is the equation that you will be able to get for the Adam optimizer. So you will be able to find out that we are not just considering, we are not just trying to consider the changes that has happened in a past. On top of that, right? On top of that, so we are trying to control almost each and everything, right? So we are trying to take the average, we are trying to consider the variances. Again, we are controlling our variances, we are controlling average shift as well by using a G square over here. And that's the reason, that's one of the reason you can say that Adam optimizer is one of the widely used optimizer in most of the use cases that you are going to solve going forward. So many people try to use this Adam optimizer directly instead of using a ADA delta, instead of using a RMS prop, instead of using a ADA max, instead of using like a ADA grade, right? So instead of using a Newton's equation, so people generally try to use an Adam optimizer, because here in terms of regularization, so we have regularized almost each and everything in each and every places, right? So this is what we have done in a Adam optimizer. And even in your case, right? So whenever you're trying to solve some of the, like whenever you're trying to solve some of the use cases in a deep learning, whenever you're trying to train your own model in a deep learning, so you are supposed to consider Adam optimizer. You are supposed to test your model with the Adam optimizer as well, because Adam optimizer, there is a huge possibility that it will be able to learn. It will help you to learn your model in a better way, because there is a huge control that people have given over here, where researcher has given a huge control on top of each and everything. So this is like a just an equation that you are supposed to remember. And people generally ask a question that, okay, fine, so tell me something about Adam optimizer, right? So you can say that, okay, so Adam optimizer is basically a momentum based optimizer. That is true. Now, what is the meaning of momentum? So meaning of momentum over here is very simple, that if I'm trying to make some changes, so it should not depend upon just a current changes, right? It should also depends upon the past changes that I have done, all the past changes. Now you can say that Adam optimizer always try to gives us a better control over to this regularization that we are going to do. So it is going to give us a better control over to the average of the gradient that we are going to consider. It is going to give us a better control over to the variances that we are going to consider. And if this is the kind of control which I will be able to get. For sure, I will be able to optimize my weight in a much, much better way, right? So here we have a control over to the gradient. So we have a control over to the gradient. We are not creating taking a gradient directly, and we have a control over to the learning rate as well. In the past equation, the Adam optimizer, or like a ADA, sorry, not Adam optimizer. So ADA delta, ADA grade, and in RMS prop optimizer, we have seen that we were trying to take a control over to the eta value, over to the learning rate. But here we are trying to take a control even to the gradient. So we are not considering a gradient directly, right? We are trying to factorize it, and the factor of that we are going to consider in a final equation, right? In a final equation, this is what we are going to consider. So this is how Adam optimizer is going to work, or this is how Adam optimizer is going to behave with so much of control. Okay, so okay, so I think all of you are able to understand it, right? So anyone who is having any kind of a question, any kind of a concern, so you can try to like post your question in a chat box, and I will try to answer each and every questions that you have. Yeah, go ahead with your question, please. What is beta 1 and beta 2? So beta 1 and beta 2 is a constant value. So you can say that beta 1 is equal to 0.9. And again, even beta 2, you can try to consider as a 0.9, right? Or 0.8. So beta 1 and beta 2 is a constant, and even epsilon is a constant that is given to you. So value of epsilon is nothing but 10 to the power minus 8. So whenever like we are trying to, why epsilon? We are trying to consider over here because it could possible that variances will be equal to 0, right? It's possible because variance is nothing but it's the way data is going to vary. Let's suppose my speed is constant 10 10 10 10 10, means I'm trying to there is no variations you will be able to find it. Variations is equal to 0 in this particular case because everywhere my speed is constant, right? And in that case I can say that okay, so I have started from 10 and I'm trying to maintain a constant itself. Let's suppose if you're like in between some time interval, if you're trying to drive a car, but if your velocity is constant, so in that case you can say that there is no variances in a velocity, right? Or maybe if you have just parked your car, so again there is no variances in terms of velocity that you will be able to find out. Speed is equal to 0, right? So for that particular factor, it could possible that total variances is equal to 0, and if total variances is equal to 0, right? If this denominator term is equal to 0, and if we don't have this epsilon term, so in this case anything divided by 0 is equal to infinity. And this is something that you can't consider, right? So just to regularize this one, people have introduced, or researcher has introduced, this particular factor called as epsilon, and the value of epsilon they have kept it as a very small 10 to the power minus of 8, so that at least like in case of variance is equal to 0, so it can maybe try to start from a very huge value of a eta, right? Because if 10 to the power minus 8 we are going to consider in a denominator, right? So in that case eta value will be too high, so we can try to start from the very high learning rate. We can say that okay fine, so my data set is like too much dispersed, and in that case I can try to start from the like a huge value of the eta, and then I can try to start decaying in this particular way. Okay, is it the variances of the weight we are trying to control? No, variances of the gradient that we are trying to control, as you can see very clearly over here. So like a VT is nothing but VT minus 1 and a gradient term, right? So variance of the gradient that we are going to control. I think I have already mentioned very clearly over here. Okay, someone is saying that what is the meaning of uncentered variances? So uncentered variances is simply means that so where you will not be able to define equal variances in both the direction, right? So that is called as uncentered variances. So suppose if you are trying to travel from here to here, and if you're trying to travel here from here, right? So again, so variances is different in this step and variances are different in this step. So this is called as uncentered variances. Okay, so the next question is, can you take a lecture on gradient descent? I think I have already done that, a gradient descent. And this is what we are talking about, right? So we are talking about a gradient descent itself. So we are talking about the variance of gradient descent itself. So gradient descent is basically like a term where like how you will be able to change the weight. So everything is basically comes under gradient descent itself. So difference between SGD with momentum and atom, right? See, momentum is basically a kind of SGD. Now SGD is basically a way to pass data. Even in my doubt clean session, so I was trying to explain you that whenever you are going to take W new is equal to W old and eta dE by dW, right? So this is the original equation. This is the equation from where the actual story has started, like how we are going to change the weight, right? So while we are trying to change the weight, so if we are going to consider SGD, so in that case, we can simply say that we will try to pass only one data and then we will try to do a backward propagation. BGD means whole data and then backward propagation. MGD means a bunch of the data and then a backward propagation, right? Now, so whenever we are trying to talk about SGD with a momentum, you will have to define that which momentum equation you are going to consider. So means SGD means one data with which momentum, whether it's a atom, whether it's a ada delta, whether it's a ada grade, whether it's a RMS prop, whether it's a Newton's equation, whether it's a ada max, right? So these are the different kind of like a momentum equation that you will be able to find out. So basically SGD is a way to pass a data. SGD, BGD and MGD. Even I have explained very clearly in our previous classes that SGD was or BGD or MGD was a initial approach to change the weight based on this simple equation where we don't have any kind of a control or we were not considering any kind of a momentum or a last changes when we are trying to do a current changes, right? We were not considering any kind of a factor with respect to a eta or with respect to a gradients that we are trying to find out. Simple, in the simplest possible way. Okay, so is Adam the most optimized version of the GD or there are more recent optimizer better than Adam? So you can say that Adam is one of the most optimized version of GD, but there is something called as a Adam max that you will be able to find out, and there is something called as a N Adam that you will be able to find out, right? So basically like there is something called as a Nestrov accelerated gradient, right? In Adam that you will be able to find out. So you can say that, so people was trying to introduce these kind of a equation. You can say that like it's sometimes it works better than Adam optimizer as of now in a general uses, right? So we try to use Adam optimizer because it's a best one, right? Whatever equation that we have studied so far so forth, so among all of this equation this is the best one. But I won't say that this is like a one of the best one among all the optimizer which is available. You can try to learn like a AdamX, you can try to learn N Adam, you can try to learn maybe AMS grade as well. So these are the equation which is going to give you like a better control again on top of the way you are going to optimize it. See, everything depends upon just a kind of a control it is going to give it to me. When we are trying to do a gradient descent, means when we are trying to change the weights of the equation. So whenever we are trying to change the weights in a graph, so again, so I'll just opt for those kind of equation which is going to give me a better control. Adam is going to give you a better control as of now, right? So you can try to use Adam, and in many different experiments also people have proven that, right? So people have proven that Adam always performs well. Adam always performs in a better way as compared to like all the algorithm which is available as of now. So Adam is used on top of which basic optimizer among BGD, SGD, MGD. So by default, you will be able to find out in some of the library with respect to SGD, right? But you can try to give BGD as well. You can try to give MGD as well. You can try to set your batch size as well. So you can try to use with anything. Can we say that Adam is equal to RMS prop plus momentum? Even in RMS prop, there was a momentum, right? So RMS prop, even we had a momentum. So no, this statement is wrong actually. is the under root is only on V or on E? So only on V. Okay, so now let me just share my screen so that I will be able to like show you. Yeah. So yes, we were talking about like different kind of optimizer, and here, so we have seen over here that the meaning of Adam optimizer adaptive momentum estimation is the another method of like computing basically a adaptive learning rate based on the momentum for each and every parameter, right? And here, so in this addition to to storing the exponentially decaying average of the past square gradient like a data or RMS prop, right? So Adam also keeps an exponentially decreasing average of the past gradient similar to the momentum, right? So Adam can be used as a combination of a ADA grade and RMS prop. Someone was saying that RMS prop plus momentum, so which is not true. So you can say that it's a combination of a ADA grade equation that we have discussed, and it's a combination of a RMS prop that we have discussed in our past. So like a ADA grade was the equation which works well with the sparse data set. Means suppose if I have some classes, and if some classes is available in a less volume on a sparse gradient, and RMS prop we have discussed, so which works well with the online and non-stationary data set, right? So basically it's a combination of, you can say, ADA grade and a RMS prop equation that we have discussed. And yes, so computation wise, right? So if I'll talk about a computation, if I'll talk about the computation, so even computation wise, so it is efficient, and it will always try to consume a less amount of a memory. But again, it's a subjective term, right? So let's suppose if I'm talking about a BGD, right? So in case of a BGD, so if it is going to consider all the data, and then it is going to calculate the average loss, and then it is going to send that average loss inside the optimizer again, so you will be able to find out that you are going to get mom issue. So means memory out of like memory out of bound kind of exceptions you will be able to find out, which is a very common in a TFOD like a classes. So like many people used to get that kind of a issue, and in that case we try to advise people that try to decrease your batch size, and that is going to fix that particular issue. So yes, it depends upon like what is the batch size that I'm going to consider, what is the step size which I'm going to consider. But as far as a popularity of this algorithm is concerned, so Adam optimizer is one of the most popular, most effective optimizer that you will be able to get till date, right? Yes, there are a better optimizer. Like I said, there is something called as AdaMax, which is available. There is something called as basically like a Newton's equation, which is also available, and many more optimizers which is available. But yeah, so you should use in general Adam optimizer. Now if you will talk about like this one, if you'll talk about like the way it is going to decay itself, so here in a picture it's been mentioned very clearly, right? There is also called as N Adam, which is available, right? So here if you will try to compare, right, so this is how like this entire thing is going to decay. And here with respect to a color, you will be able to find out that which is decaying in a faster way, or which is trying to achieve a minima. Star is basically a point where we are supposed to reach. So this star is basically a point where we are supposed to reach. And here you will be able to find out that this yellow one is trying to reach on a very first place. And so yellow one is trying to reach out in a very first place. And then like there is something called as a like a momentum. So if I'm just trying to consider a plain momentum, so I'm not considering any of these factors. So in that case, like that is also trying to reach out on a very first place. And SGD, if I'm just trying to consider SGD, so SGD is basically represented by red color. The SGD is someone which is trying to reach out in a slowest possible manner, because here we are going to consider one data set at a time, random data set at a time. And for sure, so it will take time to find out a local minima for the entire data set, or it will like find difficulties to generalize the entire data set, right? Now, so again here comparison you will be able to find out. So other delta is like a trying to decay, right? But again, if I'll talk about like a SGD, so yeah, so it is like it is trying to take some kind of some time as compared to any other algorithm, right, to reach out to the a minima point over here, or a local minima point over here at any point of a time, right? So whenever you are trying to choose an optimizer, so what in all facts, or what in all things that you are supposed to keep in your mind. So if data set is sparse, right? So sparse means, so whenever there is some classes which is available, whenever there is some classes which is having a huge variances, right? So if data set is sparse, so use a self applicable method. So you can try to use ADA grade, ADA delta, RMS prop, or Adam optimizer. So I'll generally suggest people to use Adam optimizer, because it's a combination of most of the equation that we have seen or we have studied so far, so forth. RMS prop, ADA delta, Adam have a similar effect in many cases. So almost it's a same in many cases, but still Adam always works well. Adam is just added bias correction and momentum on a bias of a RMS prop. So Adam, like I said, so Adam is having always advantages for sure. As a gradient become sparse, so Adam will perform better than RMS prop, right? So as your gradient will become sparse means what? So whenever you're trying to change your gradients, whenever based on gradients, whenever you're trying to change the weight, so if it is not a regular one, if it is not changing itself in a regular fashion, so in that case Adams always works well. And again, so if you'll try to choose the, or if you'll try to find out the conclusion of this entire points, you will be able to find out that we should go ahead with the Adam optimizer instead of going ahead with any other optimizer that we have. So that's the reason, so we have mentioned this line over here. So overall, Adam is a best choice for you whenever you are trying to pick and choose some kind of a optimizer. Now you can ask me a question that if Adam is a best optimizer, then why we were not using it in almost every kind of a research paper, right, which is available. So in 1998, when a first convolution when the first breakthrough has happened, right? So when people have published, or when researchers have published a very first paper in a convolution neural network, so at that point of a time these things was not available. So this kind of equations, this kind of algorithms was not available in 2012, or after 2010. So these things has been developed, and keeping these things in mind, so you will not be able to find out Adam optimizer in a previous research paper. But nowadays, so Adam optimizer, ADA delta optimizer, RMS prop optimizer, ADA grade optimizer, N Adam optimizer, ADA max optimizer, so all of these optimizers are available in almost every libraries. Whether you are going to talk about TensorFlow 1.x, 2.x, Keras, with respect to 1.x, 2.x, or maybe PyTorch, maybe Thenos, maybe Cafe. So you will be able to find out these optimizers in almost every libraries. And yeah, so you will be able to utilize it in your architecture that you are going to design to train your own model, whether it's a CNN based model, or whether it's a transfer learning based model, or whether it's a NLP model that you are going to develop, or like a object tracking model, or whatever, right? So SGD is used in many paper, right? SGD, stochastic gradient descent, like I said, so it's one of the useful one, but in many other papers, you will be able to find out that they have very clearly highlighted. So when we'll talk about a research paper, right? So you will be able to find out that they have very clearly highlighted that SGD is not working well, right, in their cases, because SGD always try to pick and choose one random data, and then they try to do a backward propagation based on the loss calculation of one single random selected data set, right? So SGD is used in many paper without momentum, because without momentum means simple SGD. So it simply means that equation will be W new is equal to W old minus eta d by dW. This is called as SGD without momentum, or like a simple a gradient descent without momentum. When momentum comes into picture, you are supposed to use some of the momentum equation, maybe ADA delta, RMS prop, ADA grade, or Adam optimizer. Although SGD can reach a minimum value, it takes longer than other algorithm and may be trapped in a saddle point, right? So SGD try to decay itself. That is true, right? We have seen that, but we have even seen in this animation, right, that SGD is trying to take a huge amount of a time, right? So it could possible, It could possible, because it could possible that when I'm trying to send one data, when I'm trying to send first record, right, it is trying to achieve this minima. That is fine. Then second record, maybe this minima, right? Third record, maybe again this one, right? So it will keep on fluctuating. So it could possible that it will not be able to achieve an absolute minima at any point of a time, right? Absolute minimum means, so where loss is equal to 0. There is a huge possibility, there is a very high possibility that it will not be able to find out this absolute minima where loss is equal to 0, and maybe it will start fluctuating just in between. And many of this SGD, like a diagram that you will be able to find out. So you will be able to find out a diagram like this one, zigzag here. So whenever it will try to reach out to the absolute like a minima or saddle point, so you will be able to find out that it's fluctuating a lot, right? It's revolving around a minima a lot, but it is not able to fall into a absolute minima. And that's a issue. That's a kind of a issue that you will be able to find out. But at the same point of a time, SGD with momentum, if you are going to consider, right, SGD with momentum, so momentum will help them, because momentum always remembers that what has happened in a last time, right? What has happened last time, and keeping these things in mind, so they will try to change the new value. So if you are going to use SGD with the momentum, it is always like going to give you a better result as compared to SGD without momentum that we used to consider in many like a research paper that has been published like before 2010 or like since 1998, right? But nowadays we are not going to use just SGD without momentum in any of our example, any of our use cases we'll be using. But yes, you can feel free to use just a SGD without momentum just for the testing purpose, and then you can try to test your accuracy, like a performance of your model. You will be able to, like the way it is going to train it, right, the way it is going to decay the loss, right? So you will be able to find out these things very clearly, that why it's not advised to use SGD without momentum, right? But yeah, in many research paper, many early research papers, so this has been used very clearly. So this is all about like optimizer that you are supposed to know as of now, right? In terms of a theory, in terms of implementation. So we'll see how we are going to write a code for this one. Again, code is just a one word of code. You're just supposed to call like a library, Keras library, or dot, or TensorFlow library dot Adam optimizer or Ada delta optimizer, Ada grid optimizer. You are just supposed to pass all the respective values, like values in terms of beta 1, beta 2, maybe like initial learning rate, eta values, and then epsilon values you can try to control. So just have to pass all of those values and your work is done. Beta 1, beta 2, epsilon values, you can control it from your side, right? If you wanted to test it like with different values, yes, you can do that. There won't be any kind of concern at any point of a time. Now, so we are good with the optimizer. Now the next thing that we are supposed to discuss is a loss. So here let's try to talk about that, what is loss? Because when we were talking about a neural network, right, so we have seen that whenever we are trying to pass a data, inside a neural network, right, so there will be an input, that is fine. There will be an activation function, that is fine. So we talked about activation function. Now, so it is going to calculate a loss, or it is going to calculate a cost. Loss, cost or error is almost a same relative terms. Definition wise, little bit of different. And then we are going to pass our data to the optimizer, right? An optimizer will be responsible for finding out a new value of weight or new value of a biases, right? New value of a biases and new value of weight, optimizer will be able to find out. That is fine. But inside the optimizer, to calculate the gradients, right? To calculate the gradients, so we are supposed to pass what? We are supposed to pass basically a loss, right? So we should know that what and all different kind of losses are available, loss functions are available, how we can try to implement a different kind of losses, in which case what kind of a loss I'm supposed to use, right? So now let's talk about a loss function or a cost function or a error function, right? So let's try to understand this function. So whenever you are trying to send only one data, and based on that, if you are trying to calculate a loss, so or error, so that is called as a loss. Cost is nothing but, so whenever you're trying to send a multiple data and then you are trying to calculate a combined loss, average loss, so that is called as a cost, just in terms of a definition, right? This is the only differences that you will be able to find out in between loss and cost, nothing else. Error is nothing but, again, so you can say error, like it could be loss, it could be a cost. Okay. Now, so if I will try to understand what is a loss function and what is a cost function. So there are again a variety of the loss function. There is again a variety of the cost function that you will be able to find out. So in your slide itself, right? In your slide itself, so we have listed down a couple of the loss function and we have listed down a couple of the like a loss function optimizer and everything. So let's try to understand it one by one, each and everything. So the first loss function that we are supposed to understand over here is called as a L1 loss. Means how we are going to calculate a difference between y and y hat, right? So we are supposed to understand that particular part. So let's try to understand that how we can calculate a difference between y and y hat. Now, loss is nothing but calculation of a difference between y and y hat. Now, the first loss function that we can talk about is a L1 loss. The second loss function that we can talk about is a L2 loss. Now, what is a meaning of a L1 loss? What is a meaning of a L2 loss? So let's try to understand. Again, it's a very simple one, right? So L1 loss is nothing but basically it's a least absolute derivation. That is called as a L1 loss or LAD, right? Or if I'll talk about L2 loss, so it's nothing but a least squared error. So function wise, it's very much easy, right? Let's try to derive this one. So if I'll talk about a L1 loss, equation is very much simple. So it's nothing but it's a summation of I is equal to 1, right, till n at any point of a time, and then it's a absolute difference between a y minus y hat, as simple as that, or actual y and the predicted y. It's a difference between y and y hat. It's an absolute difference between a y and y hat, summation of absolute difference between y and y hat. That's the reason. So it's called as least absolute derivation as well, LAD. So in other way, so in other name of this L1 loss is nothing but it's a least absolute derivative or LAD. And if I'll talk about least squared loss, or if I'll talk about like a L2 loss, so equation of L2 loss is nothing but it's a summation of I is equal to 1 till n y minus y hat of square, right? So here you will be able to find just a modulus, just a difference between two losses that we are considering. A summation of loss we are going to consider in this particular term. So we are trying to find out the distance between these two losses, and then this is what we are going to consider. So square, it means absolute like a we are trying to consider least a squared error in this particular case. So here, right? So here you will be able to find out that L1 loss, if I'll talk about, right? So it's been used to minimize the error, which is a sum of the absolute difference between y values and the y hat values. And L2 loss will always try to do a square, summation of a square of the difference between y and y hat, right? So whenever you are going to like a L2 loss, right? So disadvantages and advantages, let's try to understand it, right? So if you will try to understand the disadvantages over here, so the disadvantage of L2 loss is nothing but, so whenever there are outliers, so the point will account for a main component of the loss. This is what I have mentioned in my slide as well. Now, what is the meaning of it? So whenever you're going to use a L2 loss, so basically, if there is an outliers, right? If there is an outliers, so it will be able to consider that as well. And based on that, so it is going to add that particular factor, add that particular loss inside a L2 loss one, because it is just trying to find out the distance, not a difference, right? But at the same point of a time, if I'm trying to use L1, right? So L1 will be able to control it. So here we are just trying to find out the distance between like a y and y prediction. So here in case of a L1, right? So in case of a outliers, it will be able to control it at any point of a time. It will not try to, because here in L2 loss, we are trying to take a square. So if there is outliers, right? Now it will do the square of that one. It means that it is trying to enhance that particular outlier term. But at the same point of a time, if I'm talking about L1 loss, no, it is just taking a difference, right? It is not taking a square at any point of a time, right? So in that case, yes. So it is like a L1 loss will be much more effective in terms of data where you have a outliers, right? So it's basically like if you have outliers, right? I have mentioned in my slide that if you have outliers and if like a difference is equal to 10, so in case of a L2 loss, it will become 100 because 10 of a square. If it is 100, then 100 of a square. But in case of a L1, that is completely fine, right? So we are adding it, but we are not trying to like square it and then we are trying to add it. So in case of outliers, it's always better to go ahead with a L1 loss as compared to the L2 loss. It is like more effective in terms of outliers. So it's always advised, it's always advisable that you are supposed to use L1 loss in case of outliers, not L2 loss in case of data where you have a kind of outliers. But if you don't have outliers, it's completely fine. You can try to use this one. If you don't have outliers, if your data set is completely normalized, if your data set is like forming this kind of a curve, it's completely fine. You can try to go through this, go ahead with the L2 loss, and it is going to perform better for sure. Now, the next one, right? Now, the next loss that we are going to talk about is called as a Hoover loss, H-U-B-E-R. So let's talk about a third loss function, which is called as Hoover loss, basically. Now, so what is Hoover loss and how you are going to define a Hoover loss at any point of a time? So if I'll try to write the equation of Hoover loss in a simplest possible way, so I can write down in this way: 1 by 2 Hoover loss is nothing but y minus y hat of a square, right? So y and y hat of a square. So if y minus y hat is lesser than some delta, right? We'll talk about this one, and it will be like otherwise lesser than or equal to, or otherwise it will be nothing but a delta term y minus y hat minus 1 by 2 delta square in other case. Okay, so this is the equation that you will be able to find out. Now, Hoover loss, you will be able to find out it's a combination of a L1 loss as well as L2 loss. So we have seen L1 loss and we have seen L2 loss. L1 loss is nothing but it's an absolute difference, and L2 loss is nothing but it's a mean squared, right? Or least squared, you can say least squared, like a calculation that we used to do. Now, in case of Hoover loss, you will be able to find out both, right? You will be able to find out this one as well as you will be able to find out this one. Here, people have introduced, researcher has introduced like a new term called as delta. So they said that, right? They said that suppose if we are going to set some values of a delta over here, right? Let's suppose if I'm going to set some values of a delta over here, that parameter value of a delta, if we are going to set, and based on that, if I wanted to control, right? Based on that, if I wanted to control that, okay, fine. So if my final loss is lesser than this one, then do this, otherwise do that, right? Because we have seen that L1 loss was good, working well with the outliers. L2 loss was a kind of a function which was not working good with the outliers, but with respect to other data set, yes, it is going to work fine in terms of finding out a normalized loss. So yes, it is going to work fine for me. So basically what people have said that okay, fine, so just do one thing. So we can try to use maybe a combination of this L1 loss as well as we can try to use like a L2 loss, right? And we can maybe try to like set some parameter, set some like a threshold that, okay, so if my value is lesser than this, right? So if my value is lesser than this, so in that case, just try to use the first one, means try to use maybe like a least squared error function, or in case of like other conditions, so just try to use something else, right? So keeping these things in mind, we have our delta term. So here, if y minus y hat, means expected minus predicted, is lesser than the delta. Now delta we can try to define. If we can say that, okay, fine, so delta is equal to 0.9, means difference between these two is lesser than or equal to 0.9. If this is the only differences, we are just trying to control the outliers, simple, right? So we are just trying to control the outliers, because we know that this equation L2 loss is sensitive towards the outliers. If y hat value is equal to 10, it will try to square it, right? So It is sensitive towards the outliers. So what we can do is we can try to control in this way that, okay, do one thing. So if it is lesser than 0.9, right, use this. It's completely fine. There is no issue with that, right? Y 1 by 2, y minus y hat. But if it is greater than, right, the threshold value that I'm going to set, if difference between y and y hat is too high, it could, so it means what? It means that there must be an outliers, right? We can say that, we can assume that there must be an outliers, right? And in that case, just try to do one thing, just try to use this kind of a function, right? And again, so use this kind of function, but with some regularization, right? We are not supposed to like find out a loss which is which is going to get affected by our outliers. And that's the reason. So we are trying to find out the absolute difference. That is fine. We are trying to multiply it with a delta term minus half of delta square, right? So this is just an regulation term that we are trying to use by saying that, okay, so it's completely fine. So here in case of outliers, I will not allow, right? I will not allow to like increase my loss function. If there is, because it should not be able to, right? So the simple idea over here is, a simple logic over here is, so even if there is an outlier, it is not allow, or it should not supposed to give you a final values of a loss which has been affected by an outliers, right? So Hoover loss is one of the best possible option that you will be able to get, which is a combination of a L1 loss as well as combination of a L2 loss. Now the next loss function that we are going to discuss, that we are going to talk about, is called as a hinge loss, right? So again, let's try to understand what is a meaning of a hinge loss. So there is another function called as hinge loss, right? So hinge loss generally, like according to my like the material that I've shared with you. So hinge loss is basically being used for the binary classification problem, right? So here you will like wherever we have 0, 1, yes, no kind of cases, 1 minus 1 kind of a cases, right? So you are going to use basically a hinge loss in that particular case. So let's suppose if I'm trying to use like a SVM classifier, support vector machine, if I'm going to use, so maybe I can try to use like a hinge loss. Here I have used a Wikipedia snapshot, basically, right? A definition of the hinge loss, like, and again, so I'm trying to use basically like a function over here. So what hinge loss says, right? What hinge loss says. So basically what happens in case of a hinge loss is, so it will always try to give you a maximum, right? It will always try to give you a maximum in between 0 and y. It will always try to give you a maximum in between 0 and y at any point of a time. So suppose if I'm trying to find out the value of y, right? So in case of like a value of y, so 1 minus ty, you can say. So basically I'm trying to find out like a hinge loss. I can write my equation in this way. So hinge loss is equal to a maximum in between 0 to 1 minus ty. This is how I can try to write this equation, right? So here, right? So here you will be able to find out that that we are trying to consider just a max in between two things, and based on that, so we are trying to consider, or we are trying to calculate the loss. So just in case of a classification, if you're trying to use some kind of a classification algorithm, right, like a SVM classifier, if you're trying to use, so what classifier does, or like a precisely in a binary class classification, so what classifier does, so either you will be able to find out a 0 or 1 based on the probability factor. This is what we do. So here in this case, we are supposed to get a loss somewhere in between 0 to 1. This is the whole idea. This is the whole objective, because again, any classes will give you like a result probability value in between 0 to 1 itself, right? So if in this case, right, if in this case your y is true, so if you are trying to do like a 1 minus true value is equal to 1 itself, right? So 1 minus 2, so this entire thing will be 0. So the loss is equal to 0. Means whatever classes that you are expecting, if you are able to get that class, right? So in that case, this whole factor will be equal to 0. But here, let's suppose like you are trying to like get the classes, but you are trying to get maybe like a 0 value, right? Maybe you will be able to get a 0 value over here. Y is equal to 0. right? You are able to get. So in that case, what will happen? So in that case, maximum of 0 and 1 will be remain, and like you will be able to get loss is equal to 0, means a complete loss you are able to get. Maybe like y is equal to something else, 0.8 or something. So in that case, yes, you will be able to calculate your loss accordingly, and then you can try to use it. So Hinge loss has been used basically for the classification problem. It's not been used for the regression problem, right? And here, so wherever we have like a binary class classification, so in that case, you can try to go ahead with the Hinge loss kind of a function. Now, the another function that you will be able to find out is called as a cross entropy loss. So basically, it's a log loss kind of a function. So let me just write it down. Cross entropy loss. So cross entropy loss is nothing but it's a log loss kind of function, and I think I have written a cross entropy loss function in my neural network class itself. Let me show it to you. So I think we were working on that. So DL cross entropy loss, just to recall that equation. Okay, so if you remember this slide, right? So we have used basically a cross entropy loss. So this is the actual equation of a cross entropy loss that you will be able to find out, right? So y minus 1 log of 1 minus a to the power L, which is nothing but the final predicted values, y hat, right? Y minus log of e to the power L. So this is called as a cross entropy loss. This one is the actual equation for the cross entropy loss. If I'll just have to rewrite, right? There's nothing but y minus 1 into logarithmic of 1 minus y hat minus y into logarithmic of y hat. So this is a cross entropy or log based loss function that you will be able to find out. And in majority of the cases, we are going to use this particular function or this particular loss in our equation. So in our like a model, whenever we are going to train it. So fine, I think this is the equation. Again, no need to remember any of this equation, right? It's completely fine. You should remember the name at any point of a time. So like we talked about a Hinge loss, we talked about a Hoover loss, L1 loss, L2 loss. So when to use Hinge loss, right? So for sure, in case of a classification, binary class classification, we can use Hinge loss. When to use Hoover loss? So when we are trying to control some of the parameter based on the outliers, right? In that case, we can try to go ahead with the like a Hinge loss, right? When we try to use like a cross entropy loss. So basically like in a binary class classification task, right? So we can try to use a cross entropy loss. Why we can't use like a Hinge loss? So basically it's a logarithmic. So basically it's easy to like decompose, or it's easy to converge or to attain a local minima at any point of a time. So in that case, we can try to use like a cross entropy loss. So this is how you are supposed to remember. Again, this is the slide that we have shared with you. So cross entropy loss. So whatever derivations that we have given over here, so it's coming from here itself, the same equation. So it's a Wikipedia snapshot that we have included, right? It's a Wikipedia snapshot that we have included over here. The same thing. Now, if I'll talk about sigmoid cross entropy loss, right? So it's nothing but we know about sigmoid. So sigmoid is nothing but 1 by 1 plus e to the power minus of x, right? So in that case, you can try to introduce basically like that cross entropy loss function as a x, and then that will be a sigmoid loss. You will be able to find out. Now, softmax cross entropy loss, if I will be talking about. So I think we talked about a function. We talked about a sawtooth function. So sawtooth function is nothing but e to the power xi divided by summation of e to the power xi, right? So basically, like if I have a data set, maybe like 8, 4, 2, 1, and if I'll ask you that, okay, fine, so give me a probability. So just try to like give me a probability of each and every data that we have over here, right? So in that case, you are going to use a softness function for sure. So here, let's suppose if I'm asking you that give me the probability of 8. So what you can do is e to the power 8 divided by e to the power 8 plus e to the power 4 plus e to the power 2 plus e to the power 1. And this is how you will be able to give me the probability. So softness always try to give you the probability of a n parameter. So basically, whenever you are going to use a softness cross entropy loss, so let's suppose you have to find out a probability of n number of vectors or n number of like a final outcome. So in that case, yes, you can use a softmax, and there is a softness cross entropy loss which is like also available, right? So you can just try to use it. Again, the base equation is not going to change at all. So the final like loss function, if you are going to define, so this softness cross entropy loss is nothing but, so it's negative of log of e to the power same like a yi divided by summation of total y, right? That you will be able to find out. So I think these are just a name that you are supposed to remember in a very first place, right? So like a name of L1, L2, and then Hinge, and then Hoover, and then like a cross entropy, and then like a sigmoid, and then a softness cross entropy. Because in an interview, so generally people ask a question that, okay, so what in all kind of a loss function that you have used? Generally, like we are going to use a cross entropy loss. In many of the cases, we are going to use a cross entropy loss or maybe a softness cross entropy loss we are going to use. But at any point of a time, name wise, you are supposed to remember that, okay, fine. So these are the kind of a loss function which exist in this universe. And yes, so we can try to use this loss function in this case or that case. Comparison is very much important. Same goes with the optimizer. Same goes with the activation function. Now, so if I'll try to conclude this entire like architecture of a neural network, right? So for any kind of a neural network that you are going to build going forward, right? So these are the basic component which is going to come into a picture for sure. So I think now we have at least a theoretical understanding. I'm not saying practical at all, right? At least we have like some sort of a theoretical understanding about a neural network, that how neural network works. What is a meaning of a input data that we have started, right? Input data. So let's try to recap each and everything, right? In the next 5 to 10 minutes. One, two, three, four, five. Okay, so let's suppose I have this table. In this table, I have a data, right? Just try to understand in this way, right? Don't try to understand in terms of images or something. In terms of image, we'll be having a discussion. So first of all, try to understand in this way. So let's suppose if I have this tabular data, because even this kind of a data we can try to train on top of the neural network in a much better way as compared to machine learning, right? So here, so we can try to like give x1, we can try to give x2, we can try to give x3, we can try to give x4, we can try to give x5, right? So one by one, right? One by one, we can try to send the data, right? At any point of a time. And it could possible that I can try to send maybe like a high amount of data as well, depends upon my receiver over here. So this is just responsible for taking your inputs. Simple. It does nothing except taking our inputs. Now in an internal layer, right? In an internal layer, so we can try to define a weights, right? So weights over here, 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 and weights over here. So let's suppose on layer 1, right? So we have a perceptron 1, 2, 3, 4, 5. And then let's suppose we have like in a layer 2, again, I have like a 1, 2, 3. So maybe I can try to define weight 1, 1, weight 2, 1, weight, this weight, right? So this weight is nothing but it's a 2, 2. This weight is nothing but like a 3, 1. right? In this way, we can try to define the weight. Similarly, we can try to define the weight for each and every layer. There won't be any kind of a issue at all. So similarly, we can try to define the weight in this particular one. Now, so once we try to pass a weight, so let's suppose if inside this neural network, right, 3 data is coming into a picture. So in total, the total amount of a data that it will be able to get is nothing but x1 w11, x1 w11 plus this one is going inside this, right? This one, and this one, right? So x2 w21, x2 w21 plus x3 w31. So this is the total amount of data which will go inside this one. Now here we can try to apply activation function. Now activation functions wise, it can be a sigmoid activation function, it can be a hypertangent, it can be a ReLU, it can be a leaky ReLU, it can be like a p-ReLU, it can be a e-ReLU, it can be a max out, it can be a Swiss function, right? So, or it can be a any other functions, right? We can try to consider as a activation function. So we have understood that roles and responsibility of activation functions is to non-linearize the data set as well as to do like a normalization of the data. This is what we have understood in our past. So activation functions wise, again, it's a subjective one. None of the activation function is good or bad at any point of a time. You have to experiment for sure. And with your experiment, you will you will be able to build a thought that, okay, fine. So which activation function which I'm supposed to take. Okay. Now, so activation function, that is completely fine. Now here, let's suppose you are able to get, again, there will be a weight that you are going to encounter. So let's suppose here we have a L3, right? So here we have L2. So in between L2, L3, so we have a weight, and we have a weight, right? So let's suppose this is a 0. So 1, 0, 2, 0, and 3, 0. And these are the weights that we have. So you are supposed to like get an output. Now, whenever you will try to get an output, so here you will try to keep some of the function, right? So in case of a classification, let's suppose binary class classification, I can try to keep maybe a sigmoid. So sigmoid you can use even over here. Sigmoid even you can use on an outer layer. So in outer layer, if you're going to use a sigmoid, it's not called as a activation function, right? It's basically called as a resultant function, or maybe it's called as an output function. So generally people like gets confused that, okay, fine. So we are using sigmoid in an outer layer. We are using sigmoid even in a hidden layer, right? So this L2 is nothing but it's a hidden layer, right? This is the output layer. We can use same function even in both the cases, right? We can use a same function, depends with my experiments. So here I will be having an output function which is responsible for giving me some sort of an output. That is completely fine. So I will be able to get it. Now once I will be able to get an output which is called as y hat or y predicted values. Here, so you will try to calculate, or you will, because you have sent only one data as of now, right? You have sent only one data, and let's suppose if I'm using SGD based momentum optimizer, momentum based SGD if I'm using. So in case of SGD, what happens? I'll try to select randomly any of this record, and then I'll send it, right? And then I will try to calculate, I will try to get y hat. I know y for sure, right? So I will try to find out the loss. Loss I will be able to find out with the help of L1 loss, L2 loss, Hinge loss, Hoover loss, shortmax cross entropy loss, right? So they are the loss function. So I will try to find out first of all loss on top of this one, right? So once I will be able to get loss, then what I will do, I will try to send these things to the optimizer, right? So what optimizer we can use? So maybe we can try to use a with momentum optimizer and without momentum optimizer. Suppose we have defined SGD with momentum, right? With which moment? With which one? With Adam, with Ada delta, with like a Ada grade, with Newton's equation, right? With Ada max. So whatever we are going to define. So it will try to send our data to the optimizer, and then it will try to do what? It will try to do a backward propagation. Means optimizer will be responsible for changing the weights. It's a responsibility of the optimizer to find out the new weights basically. And equation, yeah, equation is going to change with the help of chain rule. So we have already seen the equation, but yeah, so same thing is going to happen, depends upon the optimizer at the same point of a time, right? If I'm opting for BGD, right? If I'm opting for BGD, what will happen? It will send all the data. It will try to send all the data one by one, because I just have like a 5 receiver over here, right? I just have a 5 receiver over here. So one by one, and it will pile up in this particular place, right? So it will try to calculate the summation of the loss over here. So you must have seen that in many of almost every loss function, right? We are using summation. So That depends, right? How many data set we are going to send, how many like steps we are going to take to send all the data. So it's completely fine. I will try to send it. Then on top of that, yeah, if I'm using MGD, mini batch gradient descent, right? So mini batch gradient descent means what? So it will try to take like a maybe some subset of the data. So generally people say that 50 to 256, but it's not a hard and fast rule. You can try to use maybe a 500 records. You can try to use maybe a 10 records. That is also a batch, right? You can maybe use a 2 data as well. That is also a batch, and that is also falls under a mini batch gradient descent, basically, right? So you can try to use. So this is just a way to pass a data. Now you can use it with momentum, without momentum. In a ancient days, like when we were trying to like when lots of research was going on this function, right? So at that point of a time, yes, people was just using a more like a this optimizer without a momentum. But nowadays, we know that okay, so with momentum it is going to perform well, and that's the reason. So you are supposed to use something with a momentum. You're not supposed to use something without a momentum. So it's always like a good to use an Adam optimizer. But yes, always better to know almost a name of each and every optimizer which is available. As simple as that. So this is something that we have discussed in terms of a neural network. So we have seen like a we have basically like seen input. We have seen like we were trying to understand the weight as well. We were trying to understand the calculation. Derivations we have seen, right? Huge derivations, chain rule derivations we have seen. And on top of that, so we have seen almost like a 10 activation function, many optimizers, and many loss functions. A kind of optimizer, activation function, loss function, which is commonly used and which is not commonly used. So that at least in an interview, so you will be able to talk about it, right? Because many people are not aware about these names itself, right? So it's like a and people, it's not like they are going to ask you some fancy questions. No, it will be like a basic question itself. But yes, you must give an answer, right? You must give an answer. And this is how like you can try to like clarify this entire idea of a training of a neural network, any kind of a neural network in a generic way. Once we'll try to introduce the architecture, then this perception will like keep on changing with respect to architecture. But even over there, we are going to perform almost a similar kind of a use cases. Architecture will be different. So different neural network architecture we are going to understand, right? So again, like in terms of CNN, in terms of RNN, in terms of vision, in terms of redirection, tracking, segmentation. So yeah, that is going to vary a lot. So fine, guys, I think we are good, right? I think we are good with respect to our neural network. So anyone who is having any questions? So for unsupervised learning, we will do a same thing. So see what happens. So yeah, network is going to be same, architecture is going to change, right? So in that case, you can maybe like try to use maybe a autoencoder kind of a thing, right? If we are talking about a neural network, so it will come into a picture for sure. Yeah. So fine, guys, let me take some question and then I'll try to move to the next topic. How to know the why in unsupervised? In unsupervised, so it's not a why that we used to find out, it's a data with the data comparison that we used to learn. You will get to know going forward in unsupervised. So yeah, we have not started with the coding class with, so it's fine. We have not even like touched a coding part at all. Please tell us the confusion metrics. Please try to go through the machine learning class then. How to evaluate a model. So people are trying to ask just they need some chance. They just start asking like any kind of just random questions from anywhere. So instead of focusing on the current topics, and this is where the problem is, I can say. Okay, so I'll just move ahead with the next topic then instead of answering less unnecessary question. Okay, so now next thing that I will be talking about is let's try to understand that what is the next step. Yeah, so in your DLCV and LP like a dashboard itself, so you will be able to find out something by students, right? So many students try to write many articles, and generally we always appreciate those kind of things. And this is again one of the article written by our students, so you will be able to find out, and it's already mentioned. And we keep on changing it. We keep on changing it, right? So it's a recent article that this person has written, Vinod Kumar, and yeah. So here you will be able to find out just like a basic definitions of a difference between a loss function and cost function, and all the loss function and cost function you will be able to find out. So it's already available in dashboard. So feel free to go through these things right now. So let's try to get into a coding part, right? So let's try to get into a coding part, which is called as introduction to a TensorFlow. So what you can do is, so you can try to download this TensorFlow, right? And we can try to do a setup first of all with respect to a TensorFlow, because what I'm assuming is like a TensorFlow will not be available with all of you. So let's try to let's try to understand a TensorFlow, and then we'll start moving ahead. Okay, guys. So everyone, you can download this TensorFlow first part, right? So introduction to a TensorFlow, and let's try to see what is there inside this one. Okay, so guys, what we have done is we were trying to understand many different things, right? That is true, and we were trying to understand basically like architecture of each and everything. Now it's time to do some hands-on as well. But before getting into a hands-on part, right? So you should know some of the libraries. You should know some of the frameworks, right? And as I have mentioned, many more frameworks over here in my very first slide itself that I was talking about, right? So there are various different kind of a frameworks which is available in a market that you can use to create a neural network, right? So you can try to create a neural network by using all of these frameworks. So there is one framework called as DL4J, it's a Java based basically framework, right? And yeah, so a deep learning 4J, basically Java based framework, which is available in a market, and it is integrated with Hadoop and Spark as well, right? So this is one of the framework that you can use, but it's not a very popular framework, because popularity of the framework depends upon the number of the people who is using it, and the number of the functionalities that they are providing, and number of the flexibility, the kind of flexibility that they are going to provide. This is based on that. So popularity we used to define, and based on that, so industry always try to adopt it. So there are many more framework which is available, but it's not like in industry so people are going to adopt each and everything. No, we always try to pick and choose one set of the framework, and then based on that, so we try to do all the kind of implementation. So similar kind of a framework you will be able to find out, which is called as a Thanos, right? So Thanos, it's not a Thanos from your Avengers. So it's basically like a name of the framework which is available, right? Then the another one is a Torch, which is from Facebook. It's called as a PyTorch actually, right? So Python based like a library is called as a PyTorch, originally developed in a C++, right? And then its variants are available even in Python. Then TensorFlow, originally developed by Google. It was Google's in-house project. In a later stage, they have made these things as an open source, right? So again, there is another library which is available, framework which is available, which is called as Cafe. So yeah, again, it's a C++ based these things based library, but again, it's been used barely used, I can say. So across the industry, right, for any kind of a implementation, for any kind of a application building, so we are going to use a TensorFlow or a PyTorch. So these are the two variants that we are going to use at any point of a time, either TensorFlow or PyTorch. Both of this library, or both of TensorFlow is from Google and a PyTorch is from Facebook, basically, and both are competitor as of now in this respect, right? So like both are competitor, both are trying to provide you a better feature, both are trying to provide you a better functionality. They keep on adding different kind of features, functionalities, so that in the easiest possible way you will be able to train your network, you will be able to like train your models, right? And yeah, so you will be able to train your model, and you will be able to like build your application, right? So in our class we are going to use TensorFlow and PyTorch both. On top of that, right, on top of that, so we are going to use a Keras API. So Keras is not a standalone framework. Keras is basically a framework which always comes with a TensorFlow. So it's just a toppings you can say on top of TensorFlow, because in TensorFlow 1.x, so if you will check a previous code, right, in TensorFlow 1.x, if you will try to like implement, this is a code which has been implemented. This is the raw code actually. This is in some of my slide, you will be able to find out TensorFlow 1.x raw implementation of neural network, right? So you will be able to find out that you will have to write like hundreds of lines of code, right, in TensorFlow 1.x if you're trying to implement it with a core TensorFlow library. But same thing if you're going to do with the Keras, right? Because Keras is a high level API. So Keras, those who have not heard about Keras, so just for them, I'm writing a name. Keras, right? So Keras is basically a high level API which will try to give you a flexibility of, instead of writing a code of 100 line, you can try to do it same thing in a one or two line, right? This is how easy it is. And again, so in terms of a readability, it's very easy. I can't even say that it's like writing a code, right? Line by line, line by line. So layer by layer, you will be able to design your network and then pass the data, train it, and your work is done, right? So this is how easy this Keras framework is. Keras library is. So basically like we are going to study TensorFlow for sure, right? TensorFlow framework we'll try to see. And whenever we'll try to build any kind of application, so we'll try to use a Keras API, right? In terms of TensorFlow. In terms of PyTorch, yes, we are going to use PyTorch directly. So in your curriculum, the way we have designed a curriculum, right? So the way we have designed a curriculum is in a different way, right? So when we are talking about a computer vision use cases, deep learning and computer vision, right? So most of the use cases you will be able to find out, implementation of use cases, you will be able to find out in a Keras TensorFlow. And in NLP section, what we have done is, so most of the implementation that we have given to you is available in a PyTorch. Yes, some of the implementations are available in TensorFlow as well, right? But most of the project, most of the application that we have given to you for like a speech to text, for the story generation, for NER kind of a things, right? For like a voice analysis and all those like code that we have given to you. So those kind of a codes are available in a PyTorch, right? So this is how we are going to progress. And again, so when you will be a part of industry, right? So no one is going to ask you, no one is going to tell you that which one you should use, because you should know that, okay, fine. So how I can use like a TensorFlow, like how I can use consume a TensorFlow model into a PyTorch model into a TensorFlow. Even this is possible. So suppose if I've trained some model into a PyTorch, I can convert into a TensorFlow compatible model, and then I will be able to utilize it, and vice versa is possible, right? We do that basically because many of these things are available in a PyTorch. Many of these things are available into a TensorFlow. So depends upon like this depends upon our requirements. So we are going to utilize it, we are going to use it. So majorly we are going to focus on two libraries, TensorFlow, PyTorch. Keras is a high level API which we are going to use as a substitute of a TensorFlow. This will be the flow that we are going to follow. So I think we are like good with that now. So to use a TensorFlow, right, by default, so by default this TensorFlow library will not be available inside your system. So you will have to do some kind of installation. You will have to like install a TensorFlow, and then you will be able to utilize it. Without that, so you can't use it. So here, let's suppose if I'm going to open up Anaconda prompt, right? Or maybe you can try to open up maybe Anaconda Navigator, right? So when you will try to open up an Anaconda Navigator, so you will not be able to find out a TensorFlow directly. Let me just try to show you. Not even a PyTorch. Even PyTorch will not be available. So I'll show you like how to install like these libraries. And yes, many of you are going to make this mistake. Many of you will get stuck for sure, right? So make sure that you watch these things with attention. Now, so here you will be able to find out that this is my base and this is my environment. Now, so if I'll try to search for TensorFlow, right? Just you can go over here, TNSOR, TNSOR, FLOW. So you will be able to find out like a, you will not be able to find out a TensorFlow installation in your system, right? So this is my system. I'm trying to show it to you. So that's the reason. So like you can find it, but in your system, so you will not be able to find out this implementation, this TensorFlow. And again, so what happens is, let's suppose if I'm working into a multiple project, right? Let's suppose I'm working into a multiple project at a time. So in one project, so I'm maybe using TensorFlow 1.4, 1.14 I'm using. In other one, I'm using like a TensorFlow like a 2.x, 2. Like a 1, 2.2 I'm using. So if this is the case, right? Let's suppose in one project I'm using Python 3.6, in other projects, so I'm trying to use Python 3.7, right? So if this is a case, so in that case, basically you need a multiple environment. You need a multiple like a project environment, so where you can try to keep a different version of the library, because going forward, it's not like in your system you're just going to execute only one project and that too in one version. It depends upon compatibility as well. And in deep learning, every one of you are going to face a huge issue with respect to a compatibility. This is how the libraries are. Basically, you will be able to find out that some libraries are not compatible with this or that, right? So you should always learn while doing a debugging that, okay, fine, so which library I'm supposed to use. It's not hard to code into a deep learning, but yes, compatibility issue, system issue, many of these things you are going to find out in a deep learning. I'm not talking about just a basic CNN kind of a model. Going forward, when you will try to do like a object detection, tracking, when you will build a project, right? Many more issues is going to come in terms of a library installation itself. So make sure that you do it by yourself and you try to practice it basically. So now what we used to do is, so we try to create a multiple environment. So suppose if I'm working into a project 1, a project 2 and project 3. So I can try to create one environment for this one environment for this one environment for this one. All of this environment will be independent of each other, right? For project 1, so that like if I'm going to make some changes into this environment, right, it should not affect this one at all. It should not affect this one. And this is possible. This is possible inside your system. This is possible in an Anaconda, right? So this is possible inside the Python. So you will be able to create a multiple environment, and you can try to install a respective version of the library, because version of the library matters a lot. Sometimes, so even if there is a changes in a minor version, right? So even in that case, your code is not going to work. This is how a deep learning is. I'm not talking about the basic like a code that we used to do a copy and paste from somewhere. I'm talking about like an actual project, right? So this is a same thing that we are going to follow. So we'll try to create a multiple environment all the time, and then we are going to execute a different kind of things into that respective environment. So in a very first place, right, what I will do is, so I will try to show you how to create an environment. So you can do one thing. You can try to hit over here. You can try to log in into your Anaconda, right, a black screen, or you can do one thing. So from your Anaconda navigator as well, you will be able to create an environment. You just have to click on create, right? And then you can try to give an environment name, which version of Python you wanted to install, right? Let's suppose I wanted to create my environment, SUDH, or maybe like I wanted to create environment for project 1. So project 1, I can try to type over here, and then I can click on, and then I can create the environment. That is fine, right? So it will take some time. It will install the dependencies, and it will be able to create it. It will take some time, at least depends upon your internet speed as well, right? So how good your internet speed is. So it is going to take some time, and then it is going to create a particular environment for you. This is something that we can do. Yeah. So Python project 1 I have created, right? So as you can see over here, that by default it has installed. By default it has installed many more things in this particular place, right? So by default it has installed Python, it has installed pip, it has installed SQLite. So this is the default one it has installed. Now let's suppose if I wanted to install a new things, right? If I wanted to install a new things, so maybe what I can do is yeah. So maybe I can try to use like a TensorFlow. TensorFlow, I can try to use, and then maybe I can try to click on this one, TensorFlow, this, and then maybe TensorFlow base, database, Egan, whatever I'm looking for. So I will be able to give like the version name, and then I will be able to install it. That is completely fine. I just have to apply, and then it will be able to install in that particular environment, right? I can try to activate this environment. Let's suppose if I have selected this environment, and now if I'll go to home, and then now if I'm going to launch the Jupyter notebook, it will be able to understand this project one environment, means whatever library which I have installed. So I can try to launch a multiple Jupyter notebook. I can try to use a multiple spider. I can try to use a multiple PyCharm, right? So where I can use a different environments. That is possible. That is possible. Just have to do a selection over here if you are using Anaconda Navigator. But many of you must be facing an issue with the Anaconda Navigator. I know about that. If you're like a system, if you're using is like a i3 or like an older version of i5, so it will take time to launch this. It will take time to launch this entire Anaconda Navigator. So what you can do is, right? So what you can do in this particular case is, so you can try to install this entire thing from the Anaconda prompt. And again, command is very simple. And yes, this is something that you are supposed to this should be on your fingertips, right? So you can try to write a command called as create, or you can write in this way, conda create -n. -n is nothing but it's for the new environment, right? I'm trying to create. Now I'll try to give a name project 2, pro 2. Maybe I can try to give, or maybe let me write project 2 itself. And then which version of Python you wanted to install. So let's suppose I wanted to install python Python is equal to. So guys, you can do it with me. Python is equal to 3.6.9. I wanted to install Python. Means what I'm trying to say is I wanted to create a new environment, right, inside my Anaconda. So conda create -n. After that, you are supposed to give your environment name. You can give my name, your name, doesn't matter. And then which version of Python you wanted to install, right? And then hit enter, right? So once you will hit enter, it will take some time. Like I told you, just click on yes. And it will take some time to install all of these packages. All of these packages it is going to install, right? Again, it is done. For me, it's done. Now, if I try to check right over here. So if I'll just try to check the environment, I just have to open it and close again so that it will be able to refresh. It's refreshing now, as you can see. Right? So so now you can see a project 2 as well, right? Now you can see a project 2 as well. And this is the same environment which I have just created over here. This is the same environment which I have created. Where is the command? Yeah, project 2 environment which I have created, right? So yes, project 2 is available. Project 2 is available over here, right? So it is reflecting the same thing, right? So you can try to create environment from Anaconda Navigator just by using some clicks, as well as you will be able to create an environment from there. Now let's suppose I wanted to launch a Jupyter notebook, right? This is the base environment by default, right? I wanted to launch a Jupyter notebook where it is supposed to use this new environment which I have created, right? Python 3.6 it is supposed to use. How I can do that? So simple. You have to write a conda activate, ACTIVATE, conda activate, and then our environment name. So what was the environment name? Which environment I wanted to activate? Project 2. Simple. So now you can see that these things have changed. This project 2 has changed. I have changed the environment, right? Now, so in this environment, because in this environment from the command line, I wanted to install maybe TensorFlow, right? So what I can do is, so I can write in this way. So I can write a pip install, because in this environment I wanted to install, right? So pip install TensorFlow. So whatever it is going to install, it is just going to install from this particular environment. It is not installing for the base environment or any other project environment. So I can try to create a multiple project environment, right? It's very simple. Conda create -n and then environment name Python version. So Python 3.6.9 if you wanted to create, or maybe 3.7 that you wanted to use, 3.8 that you wanted to use. So let me just ping this code. I think many of you will be confused, right? So Okay, so pip install, right? And then you can try to write like okay, so first of all, to create the environment, so conda create -n, and then let's suppose environment name is a project2 which I have given, and Python is equal to 3.6.9. Okay, so this is the command, guys. Let me ping it to you, right? So this is the command. Yeah, so this is the command which is available in your chat box. So you can try to use this command, conda create -n project2 from your command prompt, right? And as you can see, like it is trying to download the library, it is trying to install like all of those things. So it will take some time to install, depends on net speed as well. Yeah, fine. So now installation is done, and now I'm able to like see this message, right? Again, the same command is going to work in a Windows as well as it is going to work in a Linux machine, as well as it is going to work in a Mac machine. So like just in a Linux machine, so you will have to write activate. If you're using Linux machine, it will give you that that one. So basically like yeah, so just do it. So it is just going to install in this environment. Okay, so TensorFlow installation is done. Now if I'll try to fire Jupyter Notebook, right? Jupyter Notebook, right? If I'm going to fire Jupyter Notebook, it will give me some error. Let's see. Jupyter Notebook, right? So as you can see, like it is giving me for Linux. What is the command? When I said already that it's the same command, right? So what is the meaning of that? Okay, so now here by default, so Jupyter will not be available, right? So when you are going to create a new environment, so Jupyter Notebook is available in your base environment basically, right? But Jupyter Notebook will not be available, right? So in your so in your like okay, so for TensorFlow, yeah, so in TensorFlow, like to install a TensorFlow, so command is very simple, pip install. Pip install TNSORFLOW. Yeah. So just write this command. So, but after activating your environment, don't try to install these things in a base environment itself. Don't try to do everything into a base environment. So once you will be able to see your environment name that you have created, right? So then only you are supposed to do pip install TensorFlow so that it will be able to install in that environment only, right? It's not like something called as a rocket science. It's a very simple thing that we are trying to do. We are just trying to create an environment, separate environment for the separate installation. Now, so once these things will be done, so by default, Jupyter Notebook will not be available, right? So now what you have to do is you have to do like a pip install Jupyter, because it's a new environment. Jupyter was available in your base environment, right? From there you are able to launch it. Now, so I can try to write like a pip install Jupyter. It will install. So everything you can just install it. So pip is basically a package. It's basically a bundle. It's basically a directory where all of these bundles are available. All these packages are available. It will try to download it. Again, Conda is another package. So Conda is another a repository. Pip is another repository. So you can try to download it from anywhere. Okay, so it will take maybe 30 seconds of time for me. Okay, so now, so here, like in a project two, okay, someone is asking that how to move into a project two. It's I think like it when installation has been done, right? So it will give you like conda activate and project two name. So conda activate project two name. This is what happens when you don't focus, right? Okay, so if I have to confirm that, okay, whether there is a TensorFlow 2 or not and all those things, right? So what I can do is, so I can try to type like a Python, maybe I can try to cross verify from here itself, Python. So Python shell is on, right? I can try to write import import TensorFlow, right? As maybe alias TF, and then maybe I can try to, yeah, I'm able to import it, right? As you can see. So it means that TensorFlow installation is done. TF dot if I have to check a version, which version of the TensorFlow has been installed. So basically I'm using 2.x version, right? So in the similar way, I can try to create another environment where I can install TensorFlow 1.14. In tomorrow's class, I'll show you again. So again, I'll show you like how to create an environment first of all, and then again, like I'm going to show you how to activate those environment, how to create an environment for the TensorFlow 1.4, how to create an environment for the PyTorch, right? So it's a very simple one. Okay, so if I have to exit from here, so maybe I can try to exit, right? If I have to change the project, right? So maybe if I wanted to like get into a base again, so maybe I can try to like launch a new Anaconda prompt from here, or else what I can do is, so from here I can try to write like a conda deactivate, or maybe conda activate base, right? CONDA. COMDA. Okay, now base environment is changed, right? From base environment again, so those who are facing an issue to get into their new environment, so it's very simple, conda activate, right? And your project environment. So let's suppose this time I wanted to get into my project one, project one, right? I think I have this environment, project project one. Okay, so conda activate CONDA project one. So yeah, now I'm in project one, right? Now let's launch Python over here. Let's try to check what is the TensorFlow version, or whether TensorFlow is available or not. Import import TensorFlow as TF. Yeah, there is no model called as TensorFlow. So in this environment, there is no TensorFlow. Means whatever we have done in project two, it is not affecting my project one, right? So in project two, there is no TensorFlow like installation, even in base. So you will be able to see the same thing, right? So this is how easy it is to create an environment. So whatever use cases going forward, you will build. It's a standard procedure, right? It's not like it's because if you try to like keep everything in a single place, it is going to give you problem. It is going to give you issue. So it is always better, right, to use a different environment, right, with respect to like different things. And yeah, so TensorFlow is basically like a, you can try to install PyTorch, you can install, and many more libraries going forward, we'll see. But yes, make sure whenever I'm asking you to create or to like work on some project, right, so always create a new environment first of all, right? Don't try to like use the same environment and do an installation from the very scratch. Exit. And those who are facing an issue, right, so those who are facing an issue with installation and everything, so what I will do is let me just open up a notebook, and I'll just give you a whole sort of a command over there itself. New notebook. And okay, so here is a command, those who were sleeping or those who are not able to type it by themselves, right? So to create new environment, everything from Anaconda prompt, right? So conda create -n your project name. So let's suppose I'm giving like a symbolic project name as project one, and then Python version. So let's suppose I wanted to install python Python is equal to 3.6.9. Then once you will be able to create this environment, so to activate this environment, right, so you can try to use basically conda activate project one. Okay, so this is the environment, this is the command that you are supposed to write. Okay, so and again, so to activate the environment and to change the environment, you can try to use conda deactivate. So by that you will be able to get into a base environment by default. And now to install TensorFlow, right? So pip install TensorFlow, right? By default, it will be able to install a 2.x version, right? By default, it is taking this one. Tomorrow, I'll tell you how to install TensorFlow 1.14 as well. It's very simple. TensorFlow is equal to 1.14. Simple. But I'll tell you, I'll show you those things as well, right? Although it's a simple one. So this is just an environment that you are supposed to like create. And yeah, so by default Jupyter notebook will not be available, right? So you will have to install like a Jupyter notebook, and it should be a common practice, guys. So like you should not like once once you will do it again and again, you will have to do it, right? So it should be a very common practice for you, for every one of you. Like okay, so to install a Jupyter notebook, so pip install Jupyter notebook. Yeah, so pip install Jupyter notebook. So pip is basically a library, and if you will like go to Google, if you try to type a PyPy, so basically try to download everything from this one. So PyPy package. So PyPy is a repository where even if you are going to create something, right? So you will have to host these things over here. Okay, so this is the AutoNeuro package. So this is basically a package released by us. So even we used to release our packages as well. So even you can download. So basically it's a AutoNeuro that we have created. So all this so all this Jupyter, or whether it's a Jupyter notebook or whether it's something else that you are trying to install. So everything it is trying to install from here itself, right? And over here, so you will be able to find out our package as well. So like a AutoNeuro package, you will be able to find out in this particular one. So we also try to check in multiple projects. We also try to install these things, and you can just try to call pip install AutoNeuro and you will be able to install our packages. We'll tell you what is the package, what is the meaning of this package, what and all like a task you will be able to do it, right, by using this AutoNeuro. But yeah, so we also create our packages from our side, from my side, and we try to make it public so that all of you will be able to use it for simplify your task basically. So we'll tell you there are like multiple packages that we have released, right? So we'll talk about that in the future. Even you can create your own package, it's not a big deal at all. But yeah, so the main deal will be like what you are trying to achieve. So you can try to write a simple function and then release it, and that is also possible. And like you can create a full scale project which can help anyone, and then you can release it. So you can automate something and then you can release it. So label of those packages will be different for sure. Yeah, so fine, just try to like install it. Let me copy and paste this command in your chat box. Okay, so chat box, just use it. And yeah, so what I can do is same thing I can try to post in your this one as well. So TensorFlow, maybe I can try to create one a file here, right? New file, and let me store. Environment, create class nodes. Okay, so this is the class node, and new environment create. So now this class nodes are also available. So in your dashboard itself. So whenever you will face any kind of a issue, any kind of a problem, so in a TensorFlow section, you can go over here and you can try to check that class nodes are available. And yeah, I don't think that after this you will face any kind of a issue. So it's available in the chat box as well as it's available in your a class nodes, previous class recording. Okay, so I'm keeping this over here in a code section, guys. Yeah, so in a code section, so this new environment create nodes is available, right? So do refer this one, and your recording will be available here, basically. Yeah. So fine, guys. I think I'm done for today's class, right? And yeah, so just try to practice as much as possible. And then, so can we use a version? This one, you can use whatever version that you want. Depends upon your project compatibility. You will learn. Okay, so okay, so Siva has pinged me his article, right? So guys, you can use a Siva article as well, right? So yeah, it's good actually. whenever people like publish this articles, right? So I always like um, okay, Siva, you are from Analytics Vidya, and you are also in Aniron. That's great. Welcome to Aniron. Okay, so you can use his article, right? So yeah, you can use his article. You can just check. I have not gone through this one, so I can't say that good or bad. But yeah, it's just an environment creation, so I think it must be a good one. Yeah. Or else we have already given you a command, so you can just try to use it. Command for TF version check. So import TensorFlow and then TensorFlow dot underscore underscore version underscore underscore. Okay, so Siva is saying that not from Analytics Vidya, but my articles was featured in Analytics Vidya page. Okay, fine. So you must have written an article for them. Okay, good to know. So fine, guys, you can try to use his article again. So it's a Siva article. It's not my article. For any kind of a mistake, you can comment him, right? And you can suggest him that, okay, fine. So you can do this rectification. Let me upload that article even in like your dashboard for a future, right? So file and Siva. So if people is giving you some kind of suggestion, so please try to implement that suggestion in your article and modify it accordingly if it is possible. So page name should be installation. Yes, guys, and you can keep on writing like multiple articles. We'll discuss, we'll show, and we'll share these articles with every one of you. So keep on doing these things. Installation of okay, new environment creation, or let me put the same name. How to deal with the Conda environment. Okay, I'm giving a same name here itself, right? Environment by Shiva. Okay. Okay, so I'm just keeping these things inside this one. And there should be a tab. By student. Okay. So fine, Siva, now your article, I'm keeping it over here, right, under this tab by students, right? And guys, whoever is like going to give me your article, so for sure, I'm going to like keep it here, right? So that others can follow it, others can like take some kind of a motivation, right, from every one of you. And yeah, it's always good. It's very good to have it. Even I support these kind of things, right? So always keep on doing these things. It says that my free version has expired on a Medium. Do I need to subscribe? Yeah, so Medium doesn't belong to me. So yeah, I can't do anything. Okay, like activate project one and activate project one makes difference. No, it's fine. You can check. Shiva, so people are saying you think, people are like giving you thanks. Okay, does Keras provide high level API only for TensorFlow? Try to search something, right? This is not a Google search. Okay, so fine, guys. I'll try to take some live question today, right? So today, like I think we talked about optimizer, we talked about like a loss function. So like a name is very much important and comparison is very much important, right? So make sure that unless and until you are not aware about the comparison, so you will face an issue, right? You will face an issue for sure. So make sure that a comparison is very much important and remember those comparison, right? In an interview, from interview perspective, so this things is important, right? And yes, mathematical function is not tough at all, right? If you're able to remember it, it's fine. Let's suppose if I'm talking about Adam, right? What is a mathematical function? W nu is equal to W volt minus eta divided by V hat of t plus epsilon into M hat of GT, M hat of t, right? And again, what is V hat? So V hat is nothing but, so basically V divided by 1 minus beta 1. And what is M hat? So M hat is nothing but, so basically, okay, vice versa, beta 2. And M hat is nothing but like M divided by 1 minus beta 2, beta 1. right? And then on top of that, so what is the value? What is m? So again, it's just like a simple regular equation, right? 1 minus basically like a beta 1 into like a mt minus 1 plus 1 minus again like a t 1 minus beta 2 into gt. And in case of like a v, it will be like a gt square, right? Gradient square. So this is like a very simple equation that we have, and you are supposed to like remember if it is possible. I don't like ask people to like by heart all those things. Even if you will be able to remember like a 20% of these things, your interview will be smooth, very much smooth, right? So just try to remember. But sir, at the time of interview, we messed up with these formulas. Yeah, so the important thing is like a revision, right? So revision is very much important things. So going forward, right? Going forward, so whenever you will call Adam, right? Just do one thing. So try to like look into the formula itself, right? Try to like look into the comparison also, right? But what we used to do generally, right? We used to do a copy and paste of code. We are using Adam, right? We know that Adam is optimizer, but we don't know how it is working, right? Or we don't know like how Adam is different from other optimizers. That's a problem actually, right? And this is where you create a disaster. So if you don't want to create a disaster, so whenever you're trying to use it, recall your memory that, okay, fine, so this is the meaning of this. That's the best way to like a recall and learn all those things. Okay, Mohit, so with time. Okay, so back propagation is the only way to update the weight. No, back propagation is not the only way to update the weight. Going forward, you will learn a lot. But yeah, so in a deep learning neural network, so you will see that back propagation is the only way. But if you will move to the reinforcement learning, if you will try to study a latest research paper on a GAN, so you will be able to find out that back propagation is not the only way to train a weights. Yeah, there are multiple ways which is available. Okay, so fine guys, I think we are done with today. And how many of you are able to install, you are able to test this environment like in your system? Okay, done, install it. Okay, done. DLL issue, DLL load failed. One person is fishing. Just try to use with the command, right? So the command that I have given to you, right? Just try to like do it with that. Some of you are going to like face this DLL issue. That is fine, right? We'll take care of it in a later stage. But yeah. So it's again those who are facing some DLL issues. So you will have to do some couple of more installation, right? So yeah, but you will be able to get it. Just try to create a separate environment. GPU doesn't matter, so it will be able to select GPU and GPU. Python 2.x, they will be able, it will select GPU, TPU automatically. CUDA art issue. What you're trying to install? TensorFlow? Don't try to install TensorFlow GPU. Just try to install TensorFlow CPU by default. Just try to type pip install TensorFlow and then like use it. How to launch TensorFlow from TensorFlow is a library, first of all. Those who have asked this question, right? TensorFlow is a library. It's not launch. It's just an import that you have to do. Okay, so fine guys, I think I'm like where we should we write our article. So you can try to write your article on Medium on towards data science, but yeah, always try to write a good one, right? So that people will follow you, people will respect your work, right? Or like yeah, so Medium and this one is fine. Alok Ranjan, I can see all the question, Alok. So yeah. It's not like I don't entertain, I entertain all the questions. And again, your question is again the set of the same question which other people have asked. So I'm not supposed to answer each and every question in this way. If question is just a repeated one. Okay, while installing the, I got this message. This means that, yeah, this means that your installation is fine. I have installed TF in root. It's fine. Just create an environment and then install it there. So in that environment, so it will belongs to that one. It's fine if you have a TensorFlow in the root as well. That is like not an issue at all. Will you please disable a chat during the class? Yes, I have already done that. So now, so they can only chat with me. So going forward, should we use Windows or move to Linux? I'll show everything in Windows because majority of the crowd are using Windows, right? And so yeah, for Windows people, it's a little bit painful, but yes, majority of the people are using Windows. So I'll go ahead with the Windows. People who are able to work in Windows, so in Linux, it's easy to install. In Linux, you will not get much dependencies. We'll also talk about the environment creation in CMD. Great, Sivesh. Okay. So I think you were sleeping in last half an hour because I was trying to show you environment creation in CMD itself. I mean, like, I don't understand. Like, okay. So fine, guys. Thank you so much. Practice is important. There are lots of things which is confusing as of now, right? But with practice itself, you will be able to clarify, and you all will be able to learn, right? So just practice. Tomorrow, I will try to focus on like a TensorFlow. I will try to like discuss. I'll try to talk about like a TensorFlow, not only installation part 1.14, but also I will be talking about like libraries. Also, we'll try to create one small neural network, right, with TensorFlow, and we'll try to create one small neural network without TensorFlow, right, where we'll try to see that whether my system is able to learn some pattern or not, right? So we'll do that as well. So in a core Python, without any TensorFlow, without any libraries, right? So we'll try to do it, and then with TensorFlow, so we'll try to learn what and all like functions are there, and how we can try to like utilize those functions, how we can create a basic of neural network, right? So we'll try to understand going forward. So this is the flow. So once we'll finish TensorFlow basic, PyTorch basic, and this like a neural network, a small network creation into a Python, then we'll try to move into like a CNN part basically. So again, we'll start talking about the architecture, and then at that point of a time, it will be kind of a architecture code deploy. Simple. So this is the pattern that we'll try to follow in a like a going forward classes. GPU is not necessary. Half of the world is not having a GPU at all. Okay, fine, guys. Thank you so much. Thank you, Mahalakshmi, ma'am. So yeah, so thank you so much, and see you again in your tomorrow's class. Yeah, but practice, right? And yes, like try to like get a habit of doing a Google search. Okay, so thank you so much, and see you again, guys, tomorrow.